Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera, Shalom, Om Swastiastu, Namo Buddhaya, Salam Kebajikan. Hello everyone, my name is Divo Albeins Bramantio from the Numerical Method Class 02, lectured by Mr. Dai. Hereby, I would like to present my final project report of this Numerical Method course. My project is entitled Cost Optimization of Drilling Operations Focused on its Human Resources in the Gulf of Mexico Offshore Oil Field throughout the COVID-19 pandemic using Constraint Method. As an addition, I am using Python software to complete this project. This video was also made to continue my previous video about synopsis of this final project itself. And now, I have completely done the project until the conclusion part. Next on, you can see the outline starting from number 1, a closer look on optimization, 2, abstract, 3, introduction, 4, objectives, 5, model description, 6, expected result, 7, problem. Next on, 8, mathematical model, 9, flowchart and free body diagram, 10, experimental results, 11, validation, 12, conclusion, and the last one is my references on this project. Okay, let's go on. Number 1, a closer look on optimization. Ever heard about optimization? I have input 3 different sources for optimization. On the left side, Dictionary of Oxford Languages, optimization is the action of making the best or most effective use of a situation or resource. In the middle, Merriam-Webster, an act, process, or methodology of making something, such as a design, system, or decision, as fully perfect, functional, or effective as possible, specifically the mathematical procedures involved. And the last one, from a book entitled Numerical Methods in Engineering. Optimization is the term often used for minimizing or maximizing a function. Okay, next on, the abstract of this project. Oil and gas industries do contribute significantly to the prosperity of the people all around the world. But due to the pandemic of COVID-19, it leads to the declining of the world's oil price. By the cause of it, drilling contractor companies must create a solution in which one of the strategy is to minimize their operating costs, especially regarding to the workers' salary. In this area, we will analyze the problem in the Gulf of Mexico offshore oil field. With numerical method, we can solve it using optimization, mainly focused in the constraint method. Hereby, I have given you the keyword for this project. It is cost optimization, drilling operations, oil price, and constraint method. Next on number 3, introduction of the project. Considered being the biggest sector in the world in terms of dollar value, the oil and gas sector is a global powerhouse using hundreds of thousands of workers worldwide and generating hundreds of billions of dollars globally each year. Offshore oil and gas in the Gulf of Mexico is a major source of oil and natural gas in the US. The western and central Gulf of Mexico, which includes offshore Texas, Louisiana, Mississippi, and Alabama, is one of the major petroleum producing areas of the US. Oil production from U.S. federal waters in the Gulf of Mexico reached an all-time annual high of 1.65 million barrels per day in 2017. We cannot deny it was supported with the best human resources available in the rig. Describing its human resource, it doesn't slip off with the salary. During the breakout of COVID-19, the Brent crude oil declined to $34.65 per barrel, and West Texas Intermediate was at $32.5 per barrel on May 20, 2020. It also caused by the oversupply of oil happened just before the breakout. By the situation, an optimization of operating costs must be done, and we are going to focus in the salary of the drilling operation crew. For objectives, we have three main objectives. 1. To obtain the lowest possible cost of drilling operations focused on its human resources. 2. To obtain the best scheduling shifts for all drilling crews. 3. To obtain the list of workers assigned during the shift throughout the week. Next on, model description. In a drilling contractor X located at the Gulf of Mexico offshore oil field, there are 10 workers working shift by shift in the rig. 4 of them are tool pushers and 6 of them are roughnecks. As stated in the abstract section, this topic is going to deepen the analysis of optimization using the constraint method with the constraints available. And you can see here, it is the constraints for this project regarding the shift, regarding the salary, or even the minimum shift of each worker and the company's expenditure limit. Next on, expected result. By using the numerical method with Python software, it is expected that the result will give the best optimization possible regarding the cost of the drilling operations work shift, as well as it won't break the constraints given, whereas we are focusing the analysis with a constraint method. On the other side, we'd highly expect that the coding for the optimization using the constraint method would run successfully based on the problem given and corresponds to the flowchart made throughout the case as the solution to solve it comprehensively with the shift assignments and its schedule. Next on, 7. Problem. The problem we currently face is that the company has an expenditure of more than 70,000 US dollar in a week just to pay the salary of their workers in drilling operations, 10 workers on site. Due to the pandemic, the daily income is decreasing and the company needs to restructurize the shift of their workers to lower their expenditure in weekly operations just below 60,000 US dollars for 10 workers. In addition, they do want to create the list of the best possible schedule and its daily shift assignments for 7 days straight without reducing the work shift, still 12 hours per shift to every worker. But it will be challenging because overtime hours do occur in a week, and overtime of working hours must be appreciated with a higher rate of salary to its workers. In other words, we have two main variables in sequence. 1. Combination of every worker per shift, 2 shifts in a day for a week. 2. Total cost accounts for regular work shift and overtime hours. Next on, mathematical model. In simple words, we want to design the lowest cost schedule accounting for both regular time and overtime. We can define this mathematically as shown below, where W is our list of workers, regular cost and overtime cost are the dollar cost of a regular and overtime shift for each worker, respectively, and regular shift and overtime shifts are the total number of regular and overtime shifts for each worker, respectively. Next on the flowchart and free body diagram. You can see here, it's the drilling rig illustration and diagram for this project. It is the drilling rig that we usually see in the rig where the roughnecks are working. And next on, we can see the flowchart of this project, starting to import input data and information about list of shift, specifying who's the tool pusher, define total shift, including the assumptions, variable of decision, like the ensurement that only the available workers staffed determine the regular hours, overtime hours, and overtime trigger. This must be done respectively from the start function of flowchart. To the part 2, we can see like the input constraints, objective function, print and run optimization as the last step, and we can end the flowchart. By using this flowchart of our workflow, we can receive or we can obtain what we make or what we want as the objective. Next on, I will show you my experimental results for this project from Python software. This is the coding, the early part by starting to import the required packages like the pandas, numpy, or gurobiPy, and shift list, worker list. I'm using the easy way to tell you the worker list, not by name but by a code, like 1 to 10. And I'm specifying the tool pusher from 1, 3, 5, and 7 as the manager or the tool pusher. And the rest of it, they are the roughnecks. From this coding, we can continue to find all of the main objectives we want or we need. Next on, here is the part 2, and here on, it is the part 3 or the last one. These three screenshots from my Python in Visual Studio Code will show you the result on the next slide. And hereby is the next slide from the previous. About the optimal cost of weekly worker salary, I've received this result by running the code in Visual Studio Code of Python. The optimal cost is 50,700 US dollars, and this is shown that we successfully optimized the cost. The second one, weekly schedule. Number one means the staff or the workers are assigned, and 0 means they are not assigned. And the shift assignments was made as the weekly schedule above or point number 2. And we can see that on each shift, 2 shifts per day, only one tool pusher or manager is assigned. It shows that the result is successful. For the validation, as we can see from the previous section of the experimental results, we have taken the note that none of the results break the constraints and thus prove that the coding is qualified as a successful one. For example, using constraint method, we have decided to put out the constraint of weekly operating costs for 60,000 US dollars, and by using the optimization, we know that it will just expand for 50,700 US dollar in a week. It means that the company has saved 9,300 US dollar in a week if the limit was 60,000. But in reality, it saved more than 20 US dollar, 20,000 US dollar, because the yearly expense for a week was more than 70,000 US dollar. Next on, we can see that we have successfully fulfilled the other two main objectives to search and find out the best scheduling options with its shift assignments as shown in Figure 10 and Figure 11. Shortly, it validates the result that we do not break any of the constraints available in this case of constraint method optimization. And for the conclusion, number one, optimization in numerical method is very useful to ease and really helpful to make a convenient way of solution, especially to the impact on its daily applications because of its variety of choices like golden section, constraint method, unconstrained method, etc. Two, with the right coding, cost optimization can be really done using numerical method. In this case, we are using Python. For a constraint method with a limit of 60,000 US dollar of expenditure in a week, Python helps us to solve the problem with just 50,700 US dollar of expenses in a week. A great saving to the company indeed. And the last one, we have also found the best scheduling and shift assignments full set given throughout the coding in Python without the need to separate the code. It shows that Python as one of the available programming language is a user-friendly and easy to use for beginners, such as for engineering students or educational purposes. And for the last section of this project is the references. Hereby you can see my reference using like Department Curriculum IATMI SMUI from the Deloitte or even the Petroleum Extension Service, a book from the University of Texas at Austin. Next on, I'm taking from the Roughneck Offshore drilling rig salary Mexico this year, and even from a web focused on coding. And for the last part, the really last one for this project, I'm taking on the Al-In Shirah from the Quran, verse number 5, which means, for indeed with hardship will be ease. We do know that this project needs a lot of hard work, a lot of trying for the project to be done successfully. And we must believe, especially for the Muslim, we must believe that every hardship will be eased with the help from Allah Subhanahu wa Ta'ala. So we must be always conscious and try our hardest and our best in every project or every problem we face every day. Thank you. And I'm using the credit from Slides Go for this theme of presentation. Thank you very much. Slides Go really helpful. And I thank you for you guys on seeing, and I hope this project of mine will be very helpful to inspire others, and I hope it will be very useful to all of us to understand more and more about numerical method. Thank you and have a nice day. But before, I'm sorry and I do apologize for any mistakes that I've made during my explanation of this project, and see you. Wassalamualaikum warahmatullahi wabarakatuh.